We have discussed a few problems based upon the definition of a prime number. First problem, I am just going through all the problems that we are discussed so that the students who are listening to the class for the first time, they will come to know whatever has been missed, and the students who have understood, it will be a quick recap. Again, this question is based on definition. We have done some definition. These definition, concept 2, first two are just even prime concept, concept 2 root and concept, finding out all the prime numbers less than root and concept. The previous one, this question is based upon even prime concept. A quick recap for 1 or 2 minutes. Even prime, this concept 2. These again a power n plus b power n concept, how to check whether a number is a prime or composite. This concept number 3. Again, this is the same concept, example 2 based on a power n plus b power n concept. Concept 3. Again, what if the number of digits in a number are more? Number of digits in a number are maximum. How to find out? These concept 3 based, again a power n plus b power n. How to find out the unit digit of a number for the given numbers if the given number is a prime number. Then we have discussed the divisibility rule of 101. Concept 5, divisibility rule for 101. These are all the topics which we discussed yesterday in session 1. Concept 5. Again, this is the concept based on a power n plus or minus b power n, which is concept 6. One among the given number is a prime number. Concept 6. These finding out the least possible value. Concept 7. Least possible value. Concept 7. When the prime numbers are multiplied. When the prime numbers are multiplied. Concept 7. Same concept 7 only, but when the prime numbers are added, least possible prime number, least possible prime number, least possible prime number. Concept 7. These concept 8, which among the numbers are prime numbers, using the divisibility rules, using the divisibility rules. These are all the problems which we discussed yesterday. Quick recap. Again, same concept, similar to this concept, concept 8. 2 problems based on concept 8. This was till session 1. This was till session 1. We discussed 8 concepts yesterday in session 1. 8 concepts were covered in session 1. Today, afternoon, I took session 2. In session 2, this is concept 9, again by using the divisibility rules, divisibility rule concept, concept 9. These again using prime numbers greater than 3. Prime numbers greater than 3 which are of the form 6k plus or minus 1. These concept 10. Today afternoon we discussed this multiple variety. These also same 6k plus or minus 1 application. Concept 10 application. These fundamental principle of counting. Concept 11. These also we covered in the afternoon session. Fundamental principle of counting. Session 11. Session 11. Next one. These, what if the right hand side is a prime number? Concept 12. Concept 12. What if the right hand side is a prime number? Again 6k plus or minus 1 concept, intermediate level question. Again 6k plus or minus 1 question. 12 concepts. Again, how to find out the largest prime whose cube divides. We got the answer 997. Multiplication of multiple concepts, multiplying different concepts. Very beautiful question. 12 concepts are covered now. These again lowest prime, same similar. These again we have discussed in the afternoon this Very, very important concept. P minus 1 factorial is never divisible by P. Never divisible by P. If P is prime, P greater than 6. P greater than 6, this is concept 13. Concept 13. Concept 13. Now, we are starting with concept 14. We will be starting with concept 14. Now, listen carefully. Concept 14, session 3. High level questions, session 3. Now we will be starting with concept 13, session 3. Now listen carefully. Now see, Wilson's theorem and application. Wilson's theorem and application. Now listen carefully. First we will write Wilson's theorem. Then we will understand it. Wilson's theorem. Wilson's theorem states, reminder 1, P minus 1 factorial plus 1 when divided by P, remainder is 0 if P is prime. If P is prime. If P is prime. This is Wilson's theorem. Reminder when P minus 1 factorial plus 1 when divided by P, remainder is 0 if P is prime. Wilson's theorem is applied when the denominator is a prime number. Wilson's theorem is applied when the denominator is a prime number. By using Wilson's theorem, you can find the remainder when the numerator is divided by denominator. When the numerator is divided by denominator, you can apply Wilson's theorem. To understand this theorem, let us first take few examples. This very important point, Wilson's theorem is applied when the denominator is a prime number. When the denominator is a prime number. Please make a note of it. Extremely important. When I am taking the class, ensure that you write down in your notebook parallelly so that it will be clear to you. Suppose if I take a denominator prime number, for example 5. 5 is a prime number. Let us see whether theorem is right or wrong. Reminder 1. 5 minus 1 is 4 factorial plus 1 when divided by 5. 4 factorial is nothing but 24. 24 plus 1 divided by 25. 25 divided by 25. Remainder is 0. Hence proved. You can easily prove it by taking few examples. Suppose if I take one more example, P equivalent to 3. 3 minus 1, 2 factorial. 2 factorial plus 1 when divided by 3. 2 factorial is 2. 2 plus 1, 3. 3 when divided by 3. Remainder is 0. Remainder when P minus 1 factorial plus 1 when divided by P, remainder is 0 if P is a prime number. We will do various kinds of questions based upon this. Wilson's theorem is applied when the denominator is a prime number. This is the theorem and just basic examples. Now we will get into problem solving. First question. All the questions whatever we are discussing are advanced level question. Listen carefully. Listen carefully. Now, reminder when 16 factorial divided by 17. First method 1. Method 1. Then I will discuss method 2. Reminder when 16 factorial is divided by 17. Method 1. Now if you see 16 factorial divided by 17. This is nothing but we know the Wilson's theorem. P minus 1 factorial plus 1 when divided by P, remainder is always 0. So what I did is to the numerator I added 1 and I subtracted 1. I added 1 and I subtracted 1. P minus 1 factorial plus 1 minus 1 divided by 17. I added 1. Why? Because according to theorem, P minus 1 factorial plus 1 when divided by P, remainder is 0. 0 minus 1 is minus 1. Negative remainder is minus 1. For example, 23 divided by 5. 23 divided by 5. 5 4s are 20. Positive remainder is 3. Negative remainder will be 5 5s are 25, it is minus 2. So if you get a negative remainder, to get the positive remainder, just add the denominator. 5 fours are 20, positive remainder is 3. Negative remainder will be 5 fives are 25, negative remainder will be minus 2. When you get a negative remainder, add it with the denominator to get the positive remainder. I got the negative remainder because 17 minus 1 factorial plus 1 when divided by 17 is 0. 0 minus 1 is minus 1. Negative remainder if you get, add it with the denominator to get the positive remainder. 17 minus 1 is 16. 17 minus 1 is 16. Answer for this question is 16. Answer for this question is 16. Those of you who are not comfortable with the negative reminders, one more question. 20 divided by 7. 7 twos are 14. Remainder is the remaining part. 7 twos are 14. Positive remainder is 6. Negative remainder will be 7 threes are 21. 21 means negative remainder will be minus 1. Convert this question into p minus 1 factorial plus 1 when divided by p. Remainder is 0. That is the concept I used here. Reminder 1. Wilson's theorem, basic application. Example 1. P minus 1 factorial plus 1 when divided by p is 0. This is the concept which I used. Wilson's theorem is used when the denominator is a prime number. Wilson's theorem is used when the denominator is a prime number. Wilson's theorem is used when the denominator is a prime number. First example. First problem on session 3 and 25th problem on session number 3 of prime numbers. Already 24 problems we have already covered. This is the first problem. I hope it is clear. Elementary question. As and when, first I will discuss the traditional method, then I will discuss the shortcut. Now, second question. Second one. Not a single doubt you will get in the class, problem by problem, right from the basic level in the advanced level, I will go to the very high level. Reminder 1. 22 factorial divided by 23. Method 1. Method 1. Same thing, 22 factorial divided by 23. 22 factorial divided by 23. Write down in the Wilson's theorem definition format. P minus 1 factorial plus 1 minus 1 when divided by P. Write down on that format. Once you write down now, it is very clear that P minus 1 factorial plus 1 when divided by P, it is 0. 0 minus 1 is minus 1. Negative remainder is minus 1. If you get a negative remainder, add it with the denominator. 23 minus 1 is 22. For example, 13 divided by 7. 13 divided by 7. 7 ones are 7. Positive remainder is 6. 7 twos are 14. Negative remainder is minus 1. If you get a negative remainder, if you get a negative remainder, add with the denominator. If you get a negative remainder, add with the denominator. Add with the denominator to get the positive remainder. Add with the denominator to get the positive remainder. Add with the denominator to get the positive remainder. I hope it is clear. First two problems, everything will be clear to you. Just keep on listening, sir. Keep on listening. Right after the class, you will not get a single doubt in my class because you are listening to someone who has got 14 years experience in this field, and I was the South India academic head for an organization by name Career Launcher before I started Anil Nair classes. So 26th. Now write down key points. Key points. Key points. First key point. Reminder P minus 1 factorial divided by P. What we got the answer in both the cases, it is minus 1. If you get minus 1, add with the denominator. That means answer is nothing but P minus 1. as long as p is a prime number. As long as p is a prime number. Reminder 1. P minus 1 factorial divided by p. We got minus 1. If you get a negative remainder, add with the denominator to get the positive remainder. So, reminder 1, p minus 1 factorial divided by p. Answer is nothing but p minus 1 if p is a prime number. Reminder 1, p minus 1 factorial divided by p. Reminder is p minus 1 if p is a prime number. No need to do all that directly, you will get the answer. Suppose for example 72 factorial divided by 73. 72 factorial divided by 73 is minus 1. 73 minus 1 is nothing but 72. One more example. 36 factorial by 37. 36 factorial by 37. The difference should be 1. Right difference is 1. 37 minus 1 is 36 factorial. Negative remainder is minus 1. Positive remainder will be 37 minus 1, 36. I hope the first application is very clear. Remainder 1, p minus 1 factorial divided by p. Remainder is minus 1. Last example. 18 factorial divided by 19. Negative remainder is minus 1. Positive remainder is 18. Positive remainder is 18. Two problems, then the conclusion. This is the first conclusion of Wilson's theorem. This is the first conclusion of Wilson's theorem. I hope it is clear. First one. Remainder 1, p minus 1 factorial divided by p. Remainder is minus 1. If you get a negative remainder, add it. This is the first variety. Second variety. I hope it is clear. Next. Remainder 1, 15 factorial divided by 17. Kindly reply it in the live chat in case if it is clear to you. Is it clear to you? Kindly reply if it is clear to you. Kindly reply. I want all the students who are watching the video to kindly reply it in the live chat so that I will get into a next level in the advanced topic. Everybody kindly reply if it is clear to you. Kindly reply. From today onwards, there will be a lot of YouTube live classes. Ensure that you listen to the class. 15 factorial by 17. First we will do the mistake. Then we will do the method 1. Mistake. Most of the students will do this mistake. Remainder 9 when divided by 2. 2 4s are 8. Remainder is 1. 2 4s are 8. Remainder is 1. Suppose if I divide 18 by 4. 18 by 4. 4 4s are 16. Remainder is 2. Now if you observe carefully, in the first case, HCF of 9, 2 is 1. There is no factor common other than 1. But in the second case, HCF of 18, 4. 18 and 4 both are even numbers and the highest common factor is 2. Now what is happening is, if these two numbers are co-prime means two numbers are said to be co-primes if their HCF is 1. Two numbers are said to be co-primes if their HCF is 1. If they are not co-prime, then the remainder is getting affected. I hope it is clear. Right? Even though 18 by 4 seems to be like 9 by 2, but when you are doing 18 divided by 4, remainder is getting affected. Now why am I doing this? The first thing what students may do it is 15 factorial by 17. Most of the students who come from a mathematical background, they know that 16 factorial is 16 into 15 factorial. So what they will try to do it is, they will try to multiply the numerator and denominator with 16. They will try to multiply the numerator and denominator with 16. Actually here, This is the mistake. Why? Because Wilson's theorem, reminder when numerator is divided by denominator, Wilson's theorem primarily it is applied. Wilson's theorem primarily it is applied when numerator and denominator are co-prime to each other. When the numerator and denominator are co-prime to each other. Co-prime to each other means then both HCF should be 1. When the numerator and denominator are co-prime to each other, when the numerator and denominator are co-prime to each other, then Wilson's theorem is used. What you are doing is, you are making numerator and denominator not co-prime to each other. That is a mistake. Not co-prime to each other. Not co-prime to each other. Try to make it co-prime to each other. I hope it is clear. This is the mistake. Most of the students will do it. Try not to do this mistake. Try not to do this mistake. Wilson's theorem is applied when the numerator and denominator are co-prime to each other. If they are not co-prime to each other, make them co-prime and try to solve. So don't do this. Don't do this. First I will tell you. I hope it is clear. Now method 1. Now method 1. Then I will tell you the shortcut. Now method 1. Let us discuss the method 1. Now method 1. Now method 1. Now in method 1 we will use a concept known as backtracking. Backtracking. Then I will tell you a 10 seconds approach where you can solve the problem in single step. First I am discussing the traditional method. This is the traditional method. We will respect the traditional method and also we will use optimal methods wherever there is a need. Traditional method. 15 factorial by 17. Now backtracking. Just now we discussed that 16 factorial divided by 17. P minus 1 factorial when divided by P is minus 1. P minus 1. Just now we discussed it is 60. Here numerator and denominator are co-prime to each other. So 16 factorial is nothing but 16 into 15 factorial divided by 17, which is nothing but 16. I hope it is clear. Students who are from non-mathematical background, n factorial is nothing but n into n minus 1 factorial. Here we will do an important observation. That observation I am going to use it. What is that observation? Now see here, observation. Suppose if I do 9 into 7 by 2, 9 into 7 by 2. If I am doing a reminder, 9 when divided by 2, 4 2s are 8, remainder is 1, remainder is 1, 2 3s are 6, remainder is 1. As long as the numerator is less than the denominator, how many times you divide with the denominator, the remainder will not be affected. Again I am repeating it. 2 4s are 8, remainder 1, 2 3s are 6, remainder 1. As long as the numerator is less than the denominator, remainder when numerator divided by denominator, it will always be numerator. 3 divided by 7, it is 3. 5 divided by 11, it is 5. 7 divided by 13, remainder is 7. As long as the numerator is less than the denominator, numerator itself is the answer. By using that point, now see here. 16 divided by 16, 17 zeros are 0, it is 16. 15 factorial by 17, I don't know the remainder. This is what we need to find it out. So if it is x, when I further divide, if the numerator is less than the denominator, the remainder remains the same. I hope this step is clear. 16 into something when divided by x, 17 is 16. Just by looking at the question, we can say that x is 1. If I substitute x is 1, 16 ones are 16. 16 divided by 17, 17 zeros are 0. Remainder is 16. So answer for this question is, what is x value? X value is nothing but 15 factorial divided by 17. 15 factorial divided by 17. What will be the answer? 1. I hope it is clear. We are doing backtracking here. Again, I am explaining. 16 factorial is 16 into 15 factorial by 17. 16 by 17. 17 zeros are 0. Remainder is 16. Remainder is 16. What is x here? X is the remainder when you are dividing 15 factorial by 17. 15 factorial when divided by 17, remainder is x. When divided by denominator, as long as the numerator is less than the denominator, remainder will always be the numerator. X is 1. No need to do it. This is a traditional method. Then I will tell a 5 seconds approach in method 2. 5 seconds approach, I will tell it in method 2, which is a direct conclusion. First thing, we should be very comfortable with our conceptual understanding. 16 factorial divided by 70. Method 1, it is clear. It will be much more clear if I do one more problem, so that you will come to know the step by step what you are doing. Anything what you are listening it for the first time, it might not be that much clear. 20, right. We will do one more similar problem so that you will come to know. Now see. We will do one more similar problem. 17 factorial divided by 19. Every concept, every concept, minimum 2 problems we will do. Method 1. Method 1. 17 factorial by 19. Now see here. Same thing. Reminder 1. 18 factorial divided by 19. Answer is 18. Minus 1. 19 minus 1 is 18. 18 factorial is nothing but 18 into 17 factorial divided by 19. It is nothing but 18. I hope it is clear. Same like the previous case. 18 divided by 19. 19 zeros are 0. It is 18. 17 factorial by 19. I don't know the remainder. When I further divide, it does not change. So answer is 18. Just again by looking at the question, I am getting the answer x equivalent to 1. I am getting the answer x equivalent to 1. I am getting the answer x equivalent to 1. Listen carefully, especially non-enrolled students. Right after the class is over, these kind of problems, this kind of structure, very difficult to find it out, and the class is not available for public viewing after it is over. Listen carefully. When you are with me, complete focus should be there on the class. You tell to the entire world that I am studying and focus. My only role is to make you disciplined and sincere when you are there with my class. There will be no entertainment, no bakwas, no useless information in the class. A 2 hours class means it is a 2 hour subjectual class. I will teach. All you have to do is just learn from my experience. This is method 1. This is a traditional method. Then I will discuss the shortcut. Traditional method. You don't need to refer any book. All you have to do is just listen to the class. I have read so many books and I have created a structure. Now this is method 1. Now write down another key point. Key point. Very, very important key point. Reminder 1. P minus 2 factorial. P minus 2 factorial when divided by P. It is always 1 as long as P is a prime number. As long as P is a prime number. P minus 2 factorial when divided by P. P minus 2 factorial when divided by P. Remainder is always 1 as long as P is a prime number. Extremely important point. We just did P minus 1 factorial. Now we are doing P minus 2 factorial. P minus 2 factorial when divided by P, remainder is always 1 as long as P is a prime number. As long as P is a prime number. Example. You don't need to do anything. 17 factorial divided by 19. Difference is 2. Denominator is a prime number. Answer is 1. Reminder 1. 35 factorial divided by 37. 35 factorial divided by 37. Difference is 2. Reminder is 1. Third question. 69 factorial divided by 71. Difference is 2. Reminder is 1. Very important point. P minus 2 factorial when divided by P. Reminder is always 1 as long as P is a prime number. Wilson's theorem is applied when the denominator is a prime number. Wilson's theorem is applied when the denominator is a prime number. Wilson's theorem is applied when the denominator is a prime number. Is it clear to you till now? Kindly reply it in the live chat if it is clear to you. Is it clear till now? Is it clear till now? Any doubts? Any doubts? Kindly reply it in the live chat so that I can get into the next, the third level in the advanced problem. Any doubt? Any doubts? Most likely after you start attending more and more class, you can actually start creating your own questions. No need to refer any of the local textbooks. All you have to do is a neatly structured PPT with a variety of the questions I have cleared. I hope it is clear for everyone. Now, next one. Another question. Reminder 1. 21 factorial plus 1. 21 factorial plus 1. Question is 21 factorial plus 1 divided by 23. Already we know this value. P minus 2 factorial. P minus 2 factorial when divided by P. P minus 2 factorial when divided by P. It is 1 when the P is a prime number. When P is a prime number. 21 factorial divided by 23 is 1. 1 plus 1, answer is 2. Answer is 2. Answer is 2. Just write down one more question. Is 51 factorial minus 1 is 51 factorial minus 1 prime or composite? A very beautiful question. Is 51 factorial minus 1 is 51 factorial minus 1 prime or composite? Important application just now we discussed. 51 factorial divided by 53. P minus 2 factorial divided by P. It is 1. So here it is minus 1. 1 minus 1 is 0. That means 51 factorial minus 1 is divisible by 53. If a number is divisible by 53, other than 53, there is no other number which is divisible by 53 and a prime number. So answer for this question is composite. Answer for this question is composite. Answer for this question is composite. Is 51 factorial minus 1 prime or composite? 51 factorial divided by 53 is 1. 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 1 is 0. We'll do one more question. We'll do one more question. Is what is the remainder 1? 9 factorial minus 1 when divided by 11. 9 factorial minus 1 when divided by 11. 9 factorial when divided by 11. It is 1. 1 minus 1 is 0. 1 minus 1 is 0. This is an introductory question. This is just to check by using Wilson's theorem whether a number is a prime or composite. Another introductory question. We discussed what happens when the P minus 1 factorial is divided by P. We just discussed P minus 2 factorial when divided by P. Then we will get into the next level. Then we will get into the next level. We will get into the next level. Now, another question. Reminder 1. 27 factorial plus 28 divided by 29. Just now we discussed P minus 2 factorial divided by P is 1. 1 plus 28. 1, 1 plus 28 divided by 29. 29 divided by 29. Remainder is 0. Remainder is 0. Remainder is 0. Remainder is 0. Very beautiful question, sir. Please put a star mark on this question. You will not find this kind of variety of questions in any of the books. Some of them I have understood the concept and I created a question so that you will know how to apply the concept. Next question. Reminder 1. 8 factorial whole square. 8 factorial whole square when divided by 17. 8 factorial whole square when divided by 17. Now see here. Listen carefully, sir, step by step. Solution. We know that 15 factorial when divided by 17. 15 factorial when divided by 17 is 1. 15 factorial when divided by 17 is 1. 15 factorial can be written as 1, 2, 3 and so on up to 8. Next is 9, 10, 11 and so on up to 15. When divided by 17, it is 1. It is 1. 1, 2, 3 till 8, 9, 10, 11 till 15 divided by 17, remainder is 1. Now next step, see here. 1, 2, 3 till 8, it is called 8 factorial. 8 factorial. Now see, 9 divided by 17, 17 ones are 17, minus 8. 10 divided by 17, minus 7. 11 divided by 17, minus 6. 15 divided by 17, minus 2. As long as the numerator is less than the denominator, remainder does not change. I hope it is clear. 17 ones are 17 minus 8. 17 ones are 17 minus 7. Minus 6 and minus 2. Remainder 1. From 2 to 8 there are 7 numbers. 7 negatives are there. 7 negatives if I multiply I will get negative. 8 into 7 into 6 and so on up to 2 is 8 factorial. When divided by 17 is 1. So this is nothing but 8 factorial whole square divided by 17. If I multiply by negative, it is nothing but minus 1. I hope it is clear. Minus into minus plus, 1 into minus is minus 1. Negative remainder minus 1. Positive remainder 16. Answer for this question is 16. Another variety. Answer for this question is 16. Just observe the question. 15 factorial divided by 17. 15 factorial. Now here I used the definition of a factorial. N factorial is n into n minus 1 and so on up to 3 into 2 into 1. 3 into 2 into 1. 1 into 2 into 3 till 8. 9 into 10 into 11 till 15 divided by 17. 1, 2, 3 till 8 is nothing but 8 factorial. Just observe this step, sir. This step is very, very important. If you understand this step, then you will know how to solve this question. 9 divided by 17. 17 ones are 17, minus 8, minus 7, minus 6. 15 divided by 17 is minus 2. From 2 to 8, there are 7 negatives. 7 negatives, if I multiply, I will get a negative. So, minus if I multiply, plus 1 into minus 1 is minus 1. 8 factorial whole square divided by 17 is minus 1. Negative remainder minus 1. Positive remainder will be 17 minus 1, 16. Answer for this question is 16. Third concept under Wilson's theorem. First we discussed p minus 1 factorial. Next we discussed p minus 2 factorial. Next we are doing Write a different variety derived out of p minus 2 factorial divided by p. I hope it is clear. For every concept we will do minimum 2 questions. For every concept minimum we will do 2 questions. Right? Minimum 2 questions. I hope it is clear. Answer is 16. Now, ours is one of the very few YouTube channels where a YouTube live class is conducted under a very serious environment. Right? And I should appreciate all the students who are watching it. Good that you are completely engrossed in the concept. Now, next one. I hope it is clear, right? Next one. We will do one more question, then we will draw a conclusion. Now, please see here. This is 8 factorial divided 8 factorial divided by 17. How much we run? 16. Just give me 1 minute, sir. Can you please try it out? In the meantime, I'll just have a glass of water. Now, let us solve the question. 41 factorial divided by 83. 41 factorial divided by 83. This is nothing but 81 factorial divided by 83. 81 factorial divided by 83, it is nothing but 1. Same approach. 81 factorial is nothing but 1 into 2 into 3 till 81 divided by 83, which is nothing but 1. I will write down till 41 here so that it will be clear. 1 into 2 into 3 till 41 is nothing but 41 factorial. 42 divided by 83 is minus 41. 43 is minus 40. 81 divided by 83 is minus 2. Divided by 83, it is nothing but 1. I hope it is clear. Now if you see here, 41 factorial. From 2 to 41 total there are 40 numbers. 40 numbers negative is positive. So remaining is 41, 40 and so on up to 2. 40 negatives will become positive. Divided by 83 is nothing but 1. 2 into 3 into 4 and so on up to 41. These 41 factorial. So these is nothing but 41 factorial whole square when divided by 83. Answer is 1. Answer is 1. Are you all with me? Answer is 1. Answer is 1. Why I kept the previous question here and this question? There is a difference between these two questions. Otherwise, some local teachers will draw some stupid conclusion which is invalid. 41 whole factorial whole square divided by 83 is 1. I hope it is clear, right? 2, 3, 4 till 41. So, numbers from A to B. Numbers from A to B. It is nothing but B minus A plus 1. Numbers from A to B is B minus A plus 1. 41 minus 2 is 39. 39 plus 1 is 40. I hope it is clear. 41 factorial. Idea is clear, right, sir? The difference here is, now observe carefully. The difference in the both the questions is, denominator is 6 into 3 minus 1. Any prime number greater than 3, it is of the form 6k plus or minus 1. 6 into 3 minus 1. These 6 into 14 minus 1. 6 into 14 minus 1. Now if you see multiple of 6 here, it is a prime odd number or a prime number. Here it is a composite number. That is the reason answer is not the same. In one time we got the answer -1, second time we got the answer 1. Second time we got the answer 1. It all depends upon the denominator. It all depends upon the denominator, right? I hope the idea is clear, right? 81 factorial divided by 83 is 1. 81 factorial is 1 into 2 into 3 till 81 divided by 83 is 1. 1 into 2 into 3. 1 into 2 into 3 till 41, it is nothing but 41 factorial. I hope the concept 3, is it clear to you? Kindly reply it in the live chat. Kindly reply it in the live chat if it is clear to you, so that I can get into the next concept. I think there is one more question. Yes. So I think there is one more replica question. But is it clear to you? The methodology, the way to solve this question should be clear to you. We should respect the traditional method. Any student who does not have a great conceptual clarity, this year CAT 2018 is a big bamboo for the people who believed in formula based coaching. At least 700 to 800 students have got the calls or the messages saying that in my institute they taught us formula based approach, but in the examination it is all logical approach. Last year staff selection commission was a classical example. The people who are logical by nature, people who understand the root cause behind the problem, people who knows all the concepts have got an upper hand, right, over others. Beware of formula based coachings. Beware of people only telling you the simple problems in the class, making you believe that the exam only talks about simple questions. No, I hope it is clear. I want everybody to reply it. I want everybody to reply it. I want everybody to reply it. Is it clear to you, everybody? Only on prime numbers. Look at it. In A and C, we are taking the third decision on prime numbers, but in few coaching centers, they spend 10 minutes on prime numbers. Obviously, you spend 10 minutes, you spend 5 hours, you yourself will understand the kind of clarity you get it. I want each and every student to reply it in the live chat whether it is clear to you or not, so that we will solve the next problem. Clear. Kindly reply it in the live chat if it is clear to you. Of course, you will not get a single doubt in my class because I use thematic based learning in my class. World's best education system country, Finland, uses these thematic based learning. One concept, multiple problems in the class. We will not solve random problem by problem. We will take a concept, understand the concept, go deeper into the concept, go deeper into the concept, dig deeper, deep into the concept. Now you can solve this question. Now you can solve this question. 35 factorial whole square divided by 71. Now solution. Solution. Try to solve this question. Solution. Now see here. Reminder 1. 69 factorial divided by 71, which is 1. Try to solve the question. It is nothing but 69 factorial is 1 into 2 into 3 till 35. 36, 37 till 69 divided by 71. Remainder is 1. Remainder is 1. Same thing. Now see here. 1 into 2 into 3 till 35. This is nothing but 35 factorial. 36 divided by 71. 71 ones are 71 minus 35 minus 34. 69 divided by 72 minus 2. When divided by 71 is 1. From 2 to 35, total there are 34 numbers. 34 numbers. I told you numbers from A to B is B minus A plus 1. Reminder 1. 35 factorial into 2 to 35 is 30, 34 numbers, 34 negatives will become positive. These 35 factorial divided by 71, it is 1, which is nothing but 35 factorial whole square divided by 71, which is 1. I hope the idea is clear, right? So just let me do a recap. We did first p minus 1 factorial by p, then we did p minus 2 factorial by p, then we did, if you observe, this pattern is p minus 1 by 2 factorial whole square when divided by p. Am I right? See, 71 minus 1 by 2, 70 by 2, 35 factorial whole square divided by 71. Three patterns we did: p minus 1, p minus 2 and p minus 1 factorial by 2 whole square. P minus 1 by 2 factorial whole square when divided by p. I hope the idea is clear. Shall I get into the next concept? Kindly reply it in the live chat. Shall I get into the next concept? Next concept. Kindly reply it in the live chat so that we will discuss higher level concepts. Prime numbers, not a single doubt, you will get it in the class. Next concept is a reminder when p minus 3 factorial when divided by p. How much it is? P minus, right? P minus 3 factorial divided by p. In p minus 1 by 2 factorial, it all depends upon which multiple of 6 is there. There are two conclusions that can be drawn, which is explained. Depending upon the 6 multiple, you take the necessary conclusion. Yes, Kamlakar. Right? No, it could be Ajmal, it could be 6n plus 1 also. You can take an example and try it out on your own beta. Suppose, for example, now why I did 6n minus 1 is, suppose if I take 19, you try this question on your own, Ajmal beta. 9, which is nothing but 6 into 3 plus 1. First you do the traditional method. You take one odd prime multiple of 6 and composite multiple. You can derive your own conclusion. Good doubt you have asked. 14 factorial divided by 17. Now see here. Solution. Solution. Method 1. Method 1. Method 1. 14 factorial by 17. So what I will do is 15 factorial by 17, which is nothing but 1. 15 factorial by 17, which is nothing but 1. 15 factorial. 15 into 14 factorial divided by 17, remainder is 1. 15 into 14 factorial when divided by 17, remainder is 1. Remainder 1. 15 when divided by 17, 15 when numerator is less than denominator. 14 factorial when divided by 17, I don't know the x. When I further divide, remainder does not change. I hope the second step is clear. Third step, the definition of 15x when divided by 17, remainder 1 is 15x when divided by 7, quotient I don't know k, remainder is 1. Suppose example, 9 when divided by 2, 2 4s are 8, remainder 1. 9 is nothing but 2 into 4 plus 1, which is nothing but dividend equivalent to divisor into quotient plus remainder. Divisor into quotient plus remainder. This is the concept which I am going to use here. Dividend is nothing but divisor into quotient plus remainder. So dividend here it is. Here dividend is 15x. Dividend is nothing but divisor into quotient plus remainder. Till here I hope it is clear. 15x equivalent to 7k plus 1. Now if you observe here, 7. What is 7k equivalent to 15x minus 1? 7k is nothing but 14x plus x minus 1. Now if you observe, this is divisible by 7, this is divisible by 7. X minus 1 should be divisible by 7. X minus 1 should be divisible by 7. So what is x minus 1? If I put x value, I hope it is clear, right? Till now it is clear, right? 15 factorial. Any doubts? So I am doing it with 70. It is 17. Sorry, it is 17. Now I think there are small mistake which I did. It is 17. I did it as 7. So now it will be clear. Now if you see, 15x is nothing but 15k plus 2k plus 1. 15k plus 2k plus 1. This is divisible by 15, divisible by 15. 2k plus 1 should be divisible by 15. So k value is nothing but 7. If k value is 7, 15x is nothing but 119 plus 1, 120. X value is 8. X value is 8. Answer for this question is 8. I just took 7 instead. I need to take 17, but in hurry I took it as 7. I hope the idea is clear. 15 factorial by 17. 15 into 14 factorial when divided by 17. 15 divided by 17 is 15. 15 divided by 17 is 15. Next one, 14 factorial divided by 17 is x. Dividend equivalent to divisor into quotient plus remainder. 15x is 17k plus 1. So 15x is 15k plus 2k plus 1. 15x is divisible by 15. 15 is also divisible by 15. 2k plus 1 should be divisible by 15. 2k plus 1 is 15. K value is 7. If I resubstitute in the equation, 15x equivalent to 17 into 7 plus 1, 120. X value is 8. Answer for this question is x value 8. This is method 1. Method 2, direct answer we will write. I hope method 1 is clear, right? Only thing here is this you should know. Divisor into quotient plus remainder, and how to use this identity. These two steps are important. P minus 2 factorial divided by P is 1, and dividend equivalent to divisor into quotient plus remainder. X is 8. As usual, one more question so that it will be clear to you. It will be clear to you. Now see the next question. We will do one more question so that it will be clear to you. Reminder 1. 8 factorial when divided by 11. Method 1. Same approach, try to solve. Reminder 1. 9 factorial when divided by 11. P minus 2 factorial, it is 1. 9 factorial is nothing but 9 into 8 factorial divided by 11 is 1. 9 when divided by 11 is 9. 8 factorial divided by 11 is x. When divided by 11 it is 1. 9x is nothing but 11k plus 1. What is the concept I used here? Dividend equivalent to divisor into quotient plus remainder. Divisor into quotient plus remainder. Divisor into quotient plus remainder. So 9x is nothing but 11k plus 1. 11k can be written as 9k plus 2k plus 1. 9k plus 2k plus 1. B is divisible by 9, divisible by 9. 2k plus 1 should be divisible by 9. 2k plus 1 is 9. K value is nothing but 4. If I substitute here, 9x is nothing but 44 plus 1, 45. X value is nothing but 5. X value is nothing but 5. Method 1, I am sure it is very clear to you. step-by-step approach to solve advanced level question. Basic we have completed, intermediate we have completed, now it is advanced level. 9x equivalent to 45, x value is 5. X value is 5. Now see here. You don't need to do all this. Now I'll tell you a shortcut. Praveen, what is your right? Now here Praveen beta, I used this concept. I don't know whether you missed it. I used this concept. Reminder 1, 9 into 7 by 2. 9 1 by 2, remainder is 1. 7 by 2, remainder is 1. If I further divide, remainder does not change. 9 divided by 11, remainder is 9. 8 factorial divided by 11. 8 factorial divided by 11. If the remainder is x, when I further divide, remainder does not change. This concept I used beta. This concept I used. 8 factorial divided by 11. Idea clear, right? Idea clear? Now. Idea clear? Now. Before that one. Now. I am sure it is clear, right? Now what we will do is, we will write down the method 2. Method 2. Directly how to get the answer. Method 2. Remainder 1. P minus 3 factorial divided by P. The answer is nothing but P minus 1 by 2. As long as P is a prime number. As long as P is a prime number. P minus 3 factorial when divided by P. Remainder is P minus 1 by 2 as long as P is a prime number. Directly you will get the answer. 8 factorial divided by 11, which is nothing but 11 minus 1 by 2. 10 by 2. 10 by 2. Answer is nothing but 5. Answer is nothing but 5. No need to do all this. Direct conclusion. 34 factorial divided by 37. 34 factorial divided by 37. Answer is 37 minus 1 by 2. 36 by 2. 36 by 2. Answer is 18. Answer is 18. Next one. 16 factorial divided by 19. P minus 1 by 2. 19 minus 1. 18. 18 by 2. It is 9. It is 9. Idea clear, right? So we did P minus 1 factorial by P. We did problems based on P minus 1 factorial by P. We did problems based on P minus 2 factorial by P. We did problems based on P minus 1 by 2 factorial whole square divided by P. Now we have done P minus 3 factorial divided by P. Crystal clear clarity. Crystal clear clarity. Reminder when P minus 3 factorial when divided by P. Reminder is directly P minus 1 by 2 when P is a prime number. P minus 1 by 2 when P is a prime number. P minus 1 by 2 when P is a prime number. Idea clear, right, sir? Now, advanced level in advanced level. Now, let us look at one more question. Now, it is not P minus 1, it is not P minus 2, it is not P minus 3. Difference is 6. Idea is to tell you that how you can scale up this concept to a very higher level. Now, see the solution. Neatly write down in your notebook so that not a single doubt you will get it. Once you are an enrolled student and you watch 90% of our course, you can teach the teacher actually. Right, the structure and everything. It comes from 14 years of experience and going through 3000 plus mathematical books. Neatly structured. All you have to do is buy the course and prepare a study plan, sit and learn as much as possible. As one student of mine in Delhi said, sir, I could not get into a bank PO exam because I purchased your course. Now I am earning close to 35,000 rupees by investing 7,500 rupees on your course. Right, and I have got I am taking classes in some places in Uttam Nagar or in Amar Colony in Delhi. Right, good, happy to see that students progressing in the field of teaching. 17 factorial divided by 23. Now see here. 20 factorial divided by 23. It is p minus 1 by 2. 22 by 2, which is 11. 22 by 2, which is 11. 20 factorial is nothing but 20, 19, 18, 17 factorial divided by 23, which is 11. Which is 11. 20 divided by 23, which is minus 3, which is minus 4, which is minus 5. 17 factorial divided by 23. Praveen beta, it is x. When I further divide by 23, remainder does not change. Minus minus minus, plus into minus minus. So this is nothing but minus 60x divided by 23, which is 11. 23 3s are 16, 9, minus 9, minus into minus plus, 9x when divided by 23, which is 11. Dividend equivalent to divisor into quotient plus remainder, 23k plus 11, which is nothing but 9x is 18k plus 9 plus 5k plus 2. Divisible by 9, divisible by 9, divisible by 9. 5k plus 2 should be divisible by 9. 5k plus 2 should be divisible by 9. K should not be fraction. It cannot be 9. 18 means k will be a fraction. K is 5k plus 2 is 27. K value is 5. If k value is 5, this will become 9x equivalent to 115 plus 11, 126. X is nothing but 14. Very, very good question. X is nothing but 14. Idea clear? Idea clear? 20 factorial divided by 23 is 11. If you know this, that is the reason I gave this question after the previous question. P minus 1 factorial when divided by P, it is P minus 1 by 2. P minus 1 factorial 3 factorial divided by p is p minus 1 by 2 when the denominator is a prime number. 20 factorial is 20 into 19 into 18 into 17. 20 divided by 23 minus 3 minus 4 minus 5 into x when divided by 23 is 11. Minus minus minus. 3 4s are 12, 12 5s are 60. 60. 23 3s are 16, 9, minus 9, minus into minus plus, 9x divided by 23 is 11. I hope it is clear, right sir? Everybody kindly reply it in the live chat. What is taught in your coaching centers for 15 minutes, we will be discussing all the varieties, basic, intermediate, advanced, all the varieties in the class itself, so that the enrolled student, there will be a module, prime number, session 1 basic, session 2 intermediate, session 3 advanced. Just to go through this class, after some time I think you will be better than the best, and your friends will be nowhere close to you in terms of the preparation, right? K cannot be a fraction. K is the quotient. Quotient cannot be a fraction. Kamala Karji, right? 5k plus 2 is 9. K will become 7 by 5. 5k plus 2 is 18. K will become 16 by 5. 5k plus 2 is 27. K should be a natural number. I want everybody who is watching the live class to reply it in the live chat if it is clear to you. That is the only way for me to understand whether you have understood the concept or not. Kindly reply it in the live chat if it is clear to you. Everybody kindly reply it in the live chat. Lakshman is one student who has attended my session 1, session 2, session 3. Keep up the self motivation, right? Good, Lakshman, keep it up. Continue the location. I know that all you have in your life is just the hunger to achieve success. I also know that you come from lower middle class. Everybody, I hope it is clear, right? Now let us get into few students. Why not every student? Kindly reply it in the live chat if it is clear to you. Another model, 23 factorial divided by 17. It's a very easy model. 23 factorial. 23 factorial. 23 factorial is nothing but 23, 22, 21 and so on up to 17 when divided by and so on up to 17 till 1 when divided by 17. 17 into any number when divided by 17, answer will be 0. Why? Because in this question, numerator divided by denominator. Denominator is a factor of numerator. Denominator is a factor of numerator. Denominator is a factor of numerator. If the denominator is a factor of numerator, if the denominator is a factor of numerator, if the denominator is a factor of numerator, right, remainder will be 0. I assure you that aptitude verbal reasoning, any exam which has this aptitude verbal and reasoning, just to follow the course whatever I am giving you and diligently complete the course. Trust me, take my word, you will be there in the top 10 percentage, assuming that you complete minimum 90 percentage of the course, right? An MBA prep package, students will get close to 3,500 plus videos, and we will keep updating the videos every now and then. So generally the students who are preparing for, sir, I want all your shortcuts, the best package available is MBA prep package. MBA prep package. This is an advanced level. Next. Now comes the next topic and for divisibility rules. Please write down, sir. Divisibility rule for 7, 11, 13, 77, 91. 91, 143 and 1001. 77 is 7 into 11. 91 is 7 into 13. 143 is 11 into 13. 1001 is 7 into 11 into 13. 1001 is 7 into 11 into 13. Right? Heading is divisibility rule for 7, 11, 13, 77, 91, 143, 1001. Now listen carefully. Key points. First key point. If I take remainder when 10 cube divided by 7, remainder when 10 cube divided by 11, remainder when 10 cube divided by 13, 10 cube divided by 7, 10 cube divided by 11, 10 cube divided by 13. All the three cases, remainder is minus 1. Remainder is minus 1. Why it is minus 1? We will see it. 10 cube divided by 7, 10 cube divided by 11, 10 cube divided by 13. Not only this, further numbers also. 10 cube divided by 77, 10 cube divided by 143, 10 cube divided by 91, 10 cube divided by 1001. Still it will be minus 1. Still it will be minus 1. 10 cube divided by 7, 10 cube divided by 11, 10 cube divided by 13. Now listen. Why it is? Explanation. Explanation. Suppose if I take 10 cube divided by 7. Now if you see here, 7 ones are 7. Remainder is 3. 3 cube is 27. 27 divided by 7. 7 fours are 28. Negative remainder is minus 1. 7 ones are 7. Remainder is 3. 3 cube is 27. 27 divided by 7. 7 fours are 28 minus 1. Next one. 10 cube divided by 11. 11 ones are 11. Negative remainder is minus 1. Minus 1 cube is minus 1. Similarly, if I take 10 cube divided by 13. 10 cube divided by 13. 13 ones are 13 minus 3. Minus 3 cube is minus 27. 13 twos are 26. Negative remainder is minus 1. Negative remainder is minus 1. 10 cube by 7, 10 cube by 11, 10 cube by 13. 7 ones are 7, remainder 3, 7 11 ones are 11, remainder minus 1, 13 ones are 13, minus 3 cube is minus 20. So extremely important point, this one. Very, very important point. Very, very important point. 10 cube by 7, 10 cube by 11, 10 cube by 13. It is minus 1. 10 cube by 13. I hope it is clear, right? Now, please write down the divisibility rule. Divisibility rule. Concept. Start from the unit digit. Start from the unit digit. Start from unit digit. Take a group of 3 digits. Take a group of 3 digits. Alternatively add and subtract. Alternatively add and subtract. Alternatively add and subtract. This is the divisibility rule for 7, 11, 13, 77, 91, 143, 1001. This is the first concept. Start from the unit digit. Why? Because, for example, A, B, C, D, E, F is there. When divided by 7 is there. Can I write it? Start from the unit digit. I am starting from the unit digit. Take a group of 3 digits. I did a group of 3 digits. This can be written as ABC into 10 cube plus DEF divided by 7. 10 cube divided by 7 is minus 1. Minus ABC plus DEF. This will become minus ABC plus DEF. This is the answer. I hope it is clear. I hope it is clear, right? Start from a unit digit to take a group of 3 digits. Why we are taking a group of 3 digits? Because 10 cube by 7 is minus 1. Why alternatively it will be plus? First it will be 10 cube. It will be 10 power 0, 10 power 6, 10 power 9. These 1. 1 means plus. 10 cube by 7 is minus 1. 10 power 6 by 7. 10 power 6 is 10 cube whole square. So it is plus, it is minus. Alternatively, it will be add and subtract. Alternatively, it will be add and subtract. Extremely important points. Extremely important point. Or take a group of 3 digits, alternatively add and subtract. Take a group of 3 digits, alternatively add and subtract. Alternatively add and subtract. Now see. First we will do problems. These are theory. Now once we do problems, it will be clear. First problem. Remainder 1. 102 divided by 13. Remainder 1. 102 divided by 13. This is nothing but remainder. 102 into 10 cube plus 102 divided by 13. 10 cube by 13 is minus 1. Minus 102 plus 102. Minus 102 plus 102. What will be the remainder? Remainder will be 0. Remainder will be 0. 102 into 10 cube plus 102 divided by 13. 10 cube by 13 is minus 1. Minus 102 plus 102. Remainder will be 0. Extremely important key point. Very important key point. Any 3-digit number. Any 3-digit number written even number of times. Any 3-digit number written even number of times. Written even number of times is always divisible by. Written even number of times is always divisible by 7, 11, 13, 77 and so on up to 1001. Any 3-digit number written even number of times. Any 3-digit number If you write a 3-digit number even number of times, 2 times, 4 times, 6 times, 10 times, 12 times, if a 3-digit number is written even number of times, it will always be divisible. Why it will be divisible? Alternatively, after 3-digit number, there will be plus minus. So plus minus will get cancelled. If it is written 4 times, first and second is cancelled, third and fourth is cancelled. If it is written 6 times, first is cancelled with second, third is cancelled with fourth, fifth is cancelled with 6. Any 3-digit number written even number of times is always divisible by 7, 11, 13, 77 and so on up to 100. Next example. Reminder 1. 1, 2, 3, 1, 2, 3, 1, 2, 3. 300 times. 1, 2, 3, 1, 2, 3, 1, 2, 3. Written 300 times. Divided by 77. Divided by 77. 1, 2, 3, 1, 2, 3, 1, 2, 3 written 300 times divided by 77. Now if you listen carefully, 123 is a 3-digit number. 123 is a 3-digit number. Is 123 written how many times? 300 times. Is 300, is it even number of times? Yes, it is written even number of times. So answer is always divisible by 7, 11, 13 and its combination. Answer is 0. I hope it is clear. First example, understanding of the key point and increasing the number of times. Any 3-digit number, extremely important point. Any 3-digit number written even number of times. Any 3-digit number written even number of times is always divisible by 7, 11, 13, 77 and so on up to 1001. Any 3-digit number written even number of times. This is the first example. I hope it is clear, right, sir? First example. Second one. Second one. Idea clear, right? Second one. Suppose 2 is written 6 times divided by 143. 2 is written 6 times. So already the divisibility rule of 7, 11, 13 and so on is start from the unit digit, take a group of 3 digits. Take a group of 3 digits alternatively plus and minus. Take a group of 3 digits alternatively plus minus. 10 cube divided by 143 is minus 1. Minus 222 plus 222 is 0. Minus 222 plus 222 is 0. Another important key point. Another important key point. Any non-zero singular digit. Any non-zero singular digit. Any non-zero singular digit. Any non-zero singular digit written in groups of 6. Written in groups of 6. Groups of 6 is always divisible by. Is always divisible by. Is always divisible by 7, 11, 13, 77, 91, 143 and 1001. Any non-zero singular digit. You take any non-zero singular digit. If it is written in groups of 6. If it is written in groups of 6, it is always divisible by 7, 11, 13, 77, 91, 143, 1001. Here 2 is a non-singular digit. It is written in groups of 6. Anything that is written in groups of 6. Anything that is written in groups of 6. It is always divisible by 7, 11, 13, 77, 91, 143, 1001. start from the unit digit, take a group of 3 digits, alternatively add and subtract. That is the divisibility rule of 7, 11, 13 and so on. Second one, any 3-digit number written even number of times is always divisible by 7, 11, 13 and so on. Point number 2, any non-zero singular digit. Suppose third example, 55555. It is written 24 times, divided by 1001, divided by 1001. Any non-zero singular digit written in groups of 6. It should be in a group of 6. 24 is a multiple of 6. So answer is directly 0. No need to write it. Answer is directly 0. 1001. 1001 is 7 into 11 into 13. Anything that you write down, any non-zero singular digit if it is written in groups of 6. Next is 2, 2, 2, 2, 2, 2, 2, 2. 54 times. 54 times divided by 91. Denominator should be 7, 11, 13 and so on. 91 is 7 into 13. Groups of 6. 54 is 6 into 9. So answer is 0. Any non-zero singular digit written in groups of 6 is always divisible by 7, 11, 13 and so on. If it is not in groups of 6, how to do that also we will discuss. Any non-zero singular digit written in groups of 6 is always divisible by this number. Idea is clear, right? Now we will get into one by one problems. Important concept. Now, first question. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 when divided by 7. 1, 2, 3, 4, 5, 6. A basic understanding of the question. 1, 2, 3, 4, 5, 6 when divided by 7. Start from the unit digit. Take a group of 3 digits. 123 into 10 cube plus 456 divided by 7. 10 cube by 7 is minus 1. So this will become minus 123 plus 456 divided by 7. This is nothing but reminder. 456 minus 123 is 333 divided by 7. 7 4s are 28, 53. 7 7s are 49, which is 4. I hope it is clear. Take a group of 3 digits. Start from the unit digit. I hope it is clear, right? First question. Idea clear, right? A simple divisibility rule of 7. Start from the unit digit. Take a group of 3 digits. Alternatively add and subtract. 37th question. Another one. Reminder 123 divided by. Directly we can say the answer. 123 divided by 91. So this is nothing but 123 into 10 cube plus 123 divided by 91. 1 is, this is minus 1, answer is 0. Directly it is answer 0 because we discussed a concept. Any 3-digit number written even number of times. Any 3-digit number written even number of times is always divisible by 7, 11, 13 and its multiples 77, 91, 143 and 1001. Any 3-digit number written even number of times. I hope till now is it clear? Kindly reply it in the live chat if it is clear to you. Do not miss any single class of mine. First we have taken 6 digits, then we will increase the number of digits. Then we will increase the number of digits. Then we will increase the number of digits. Vijay has asked a question. Let me take that question. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 divided by 7. Take a group of 3 digits. Take a group of 3 digits. Alternatively plus minus plus. 678 plus 12, which is nothing but 690. 690 minus 345 divided by 7, which is nothing but remainder 1. Remainder 345 divided by 7. 7 fours are 28. 65. 7 nines are 63. Remainder is 2. These for you, beta Vijay. If it is more than 6 digits, you have given me a number which has 8 digits. I'll take a group of 3 digits, alternatively plus and minus. 678 plus 12 is 690. 690 minus 345 divided by 7. 7 fours are 28, 65, 7 nines are 63. 2. Idea clear? Now, few more questions. Reminder 1. I was about to discuss with a larger number, but anyways you have asked. 88. Reminder 88 times. 8 is written 88 times when divided by 7. Already we discussed a concept. When any single digit is written in a groups of 6, it is written in a groups of 6. What will be the answer? 0. So these 6 times it is 0. Not only 6 times, any groups of 6. 12 times it is 0. 18 times it is 0. 6 14s are 84 times it will be 0. 84 times, if the question is given it as 84 times, answer would have been 0. Answer would have been 0. I hope it is clear, right? 84 times it is 0. And what is given in the question? 88 times. So remaining how many are left? 4 8s are left. 88888 divided by 7. How much will be the answer? So take a group of 3 digits. Alternatively plus minus. 888 minus 8 is 880. 880 divided by 7. So this will be 7 12s are 84, 40, 7 5s are 35. What will be the answer? 5. Answer for this question will be 5. Answer for this question will be 5. I hope the idea is clear. Any doubts? 8888, 88 times. Same concept, 7 11 13. Any single digit written 6 times when divided by 13 is 0. It is 6 times it is 0. Not only 6 times, any multiple of 6. 12 times it is 0. 84 times it is 0. Remaining is 4 8s. 88888 divided by 13. Take a group of 3 digits. Alternatively plus minus. 880 divided by 13. 13 6 are 78. 100. 13 7s are 91. What is the answer? 9. What is the answer? 9. I hope the idea is clear. The divisibility rule for 7, 11, 13 and the combination of it 77, 143 or 91 or 1001, all divisibility rule for all these 7 numbers are same. All these divisibility rule for 7 numbers are same. Why it will be same? In our school days we have studied divisibility rule for 12 is nothing but divisibility rule for 4 and 3, because 4 and 3 are the only ways where you can write the number as a product of coprimes. 77 can be written as 7 into 11. Anyway, I will discuss in detail in Chinese remainder theorem. I hope it is clear. 35th. Next one, 5555 written 1001 times by 1001. 5555. 5 is written total 1001 times divided by 1001. Divided by 1001. So what is that we discussed? Any single digit written 6 times. Any single digit written 6 times. Answer is 0. So it is 6 times. We have to check what is the multiple of 6 till 1001. 6 times it is 0. 12 times it is 0. And the process goes 996 times it is 0. 996 times it is 0. How much is left? 5 5s are left. 555555 divided by 1001. Take a group of 3 digits, alternatively plus and minus. 555 minus 55 is 500. Answer for this question is 500. Are you all with me? I hope it is completely clear. Completely clear. Just analyze whatever I said. Just give me 30 seconds time. I'll just have a glass of water and I'll be back. Analyze all the questions, whatever I discussed. Idea clear, right? Idea clear? Next question. 1001 sevens. 7 is written 1001. Same approach, sir. 1001 7. 7 is written 1001 times. 777 1001 times divided by 1001. So these is nothing but 7 is written 6 times. It is 0. 1001 it is 0. 6 times. Similarly it goes up to 996 times. 996 times it is 0. Remaining is 5 times. 7777777 divided by 1001. Plus minus 777 minus 77 is 100. Answer for this question is 700. Idea clear, beta? Idea clear? Any doubts till now? Any doubts till now? This is just a sample, sir. Whatever I am teaching is just 2% of what is covered in our video course. In our video course, varied concepts, number system, arithmetic, algebra, geometry, modern maths, right? All the conceptual content, everything is covered. Any student who is interested in knowing about our video course, you can personally speak to me right after the class. I will help you out. The official number 80500678891. You can WhatsApp me. I'll call you back right after the class is over. Generally, there will be a huge rush in the course purchase right after the class is over. Why? Because students who listen to my class for the first time, while listening, they will realize the kind of mistake they did in joining some coaching centers and spending in thousands. Almost 48 to 50% of the students who have joined my course are the people who realized the class content, true content, after they made a mistake and said, sir, we did a mistake, now we have told our friend. 85% of the students who purchase our course are only through word of mouth.
press the bell icon on the YouTube app and never miss another update.